Let's look at solving multi-step equations. So now we're using more than 2 steps to help us solve for the missing variable. So this question here, 7 times x plus 1 equals 77, there's 2 ways that we can do it. So I'll show you both. The first is, if we remember our 2-step equations, we want to use PEMDAS, but to undo things, remember that's the whole point, we want to undo what's being done to the variable. We're going to undo going from right to left. So I don't see any addition or subtraction outside the parentheses, so I'm not going to undo that. But I do see some multiplication. So we're multiplying this parentheses by 7. So I'm going to undo that multiplication. So I'll rewrite it over here. 7 times x plus 1 equals 77. So I'm going to undo that times 7 by dividing both sides by 7. So those will cancel out, and I'll be left with x plus 1 is equal to 77 over 7 is 11. And remember, at this point, I can just take away those parentheses. I don't need them because there's nothing going on outside of them. So what's being done to the variable now? Well, I'm just adding 1. So I'm going to undo that by subtracting 1 from both sides. So these will cancel, and I'll be left with x is equal to 10. The other way we can do this is recognize that we can use the distributive property here. So if I rewrite this, 7 times x plus 1 equals 77, I can distribute this 7 into the parentheses. So I'll do 7 times x, which is going to give me 7x, and then 7 times positive 1, which is going to give me plus 7 equals 77. Now this is a 2-step equation. So I'll subtract 7 from both sides. Those will cancel. I'll get 7x is equal to 70. Go ahead and divide both sides by 7. Those cancel to 1, and I'll have x is equal to 10. So 2 ways to solve this problem. Next up, negative 8 times negative 3x minus 2 in parentheses is equal to 16. Again, I can go about this 2 different ways, so I'll do it. Let's do the reverse PEMDAS method. So outside of the parentheses, I see I'm multiplying by negative 8. So let me just undo that, multiply by negative 8 by dividing both sides by negative 8. So these will cancel, and I'll be left with negative 3x minus 2. Remember, the parentheses go away because there's nothing else outside of the parentheses on the left side of the equal sign, is equal to 16 divided by negative 8 is going to be negative 2. And then what's happening to the x now? Well, I'm multiplying it by negative 3 and then subtracting by negative 2. So again, reverse PEMDAS. I'll undo that minus 2 first. So I'll go plus 2, plus 2. These will cancel, and it just so happens that these will also cancel out and give us 0. So we'll have negative 3x is equal to 0. I'll divide both sides by negative 3 to undo that multiplication by 3. Those cancel, and I'll be left with x is equal to 0. If I want to use the distributive property method, I can just rewrite it over here. Negative 8 times negative 3x minus 2 equals 16. I'll distribute that negative 8 in, so negative 8 times negative 3x is 24x. Negative 8 times negative 2 is positive 16 equals 16. I'll subtract 16 from both sides. This is just a 2-step equation at this point. Those 16s will cancel, and then it just so happens that those 16s will also cancel out and give us 0. So 24x is equal to 0. I can divide both sides by 24. Those will cancel, and again, I'll get x equals 0. Okay, 5 times x minus 2, and then outside the parentheses, minus 3 equals 22. So let's always, a good place to start would just be the reverse PEMDAS trick to help us remember what order to undo what. So looking outside of the parentheses, or outside where the variable is trapped in, I see I'm multiplying by 5, and then I'm subtracting by 3. So let me just undo that minus 3, because remember we're going right to left, and subtraction is the first thing to undo, subtraction or addition. So I'm just going to add 3 to both sides. Those will cancel out, and I'll have 5 times x minus 2 is equal to 25. Here I can distribute the 5, or I can divide both sides by 5. I'll distribute the 5. I think that's easier. You can do whichever way you want, though. So 5 times x is 5x. 5 times negative 2 is minus 10, which equals 25. Now this is a two-step equation, so I'll add 10 to both sides. These will cancel. I'll get 5x is equal to 35. I can divide both sides by 5, and then x is equal to 7. And remember, plug it back in to see that that's the case, and let's just do that real quick. So 5 times 7 minus 2 minus 3 is supposed to equal 22. 7 minus 2 is 5, so I'll have 5 times 5 minus 3. Now we're actually doing order of operations in the right way, just a reminder. 5 times 5 is 25 minus 3, and that's definitely going to give us 22. All right, here we got 3 over 5 times x equals 9. So whenever you see a fraction as your coefficient, remember that's the number in front of the variable, all you want to do is you want to multiply that fraction by the reciprocal, which is just the fraction flipped. So all I'm going to do here is I'm going to multiply this fraction by 5/3. And I want to do that to the other side too. Whatever you do to one side, you got to do to the other side. What's going to happen over here, though, is if you remember how to multiply fractions, we just multiply our numerators and then our denominators. So I'll have 5 times 3 is 15 over 3 times 5 is 15 times x equals, remember we can write 9 as 9 over 1. And that's going to be 9 times 5 is 45. And then 1 times 3 is 3. All right, so 15 over 15, well, 15 divided by 15 is just 1, so these cancel out. So I'll just be left with x is equal to, and then 45 over 3, or 45 divided by 3 is going to be 15. All right, 2 over 9x minus 2 equals negative 8. So we'll do reverse PEMDAS as usual. I'm looking for any addition or subtraction to undo first. Here I got a minus 2, so I'll add 2 to both sides. These will cancel. I'll get 2 over 9 times x is equal to negative 6. Remember, when I have a fraction as my coefficient for the variable, and I want to undo that multiplication by that fraction, just multiply both sides by the reciprocal or the fraction flipped. So I'm going to multiply both sides by 9 over 2. These 9s over here will cancel out. The 2s will cancel out. Again, if you don't know why, just multiply the numbers first. 9 times 2 is 18. 2 times 9 is 18. And then times x. And 18 over 18 is just 1. So they'll cancel out eventually if you do it that way as well. Equals, remember, we can just write negative 6. If we want to write it as a fraction, just do negative 6 over 1. And this is going to come out to be negative 6 times 9 is negative 54. 1 times 2 is 2. Negative 54 over 2 is negative 27. So that's what we'll get for x. X equals negative 27. Okay, negative 4/7 times a equals 4. So a couple of different ways to think about it. I'll show you one. Let's rewrite a as a fraction because we're multiplying it by a fraction, so maybe it'd be nice to see it expressed as a fraction. Remember, numbers or just variables, if you want to write them as a fraction, just put a 1 underneath. So we would write this like this. Negative 4/7 times a over 1 equals 4. So we've done nothing new here, or we haven't changed the value of the equation. We've just rewritten a so that it's expressed as a fraction. Okay, now we can multiply our fraction. So I'm going to multiply my numerators together. So negative 4 times a is going to be negative 4a. And then down in the denominator, I'm going to have 7 times 1, which is just going to be 7. You also might be thinking, well, how do I decide which number, the 4 or the 7, gets this negative sign? It doesn't matter, but usually go with the numerator. Just stick that negative, if it's in front of a fraction, onto the numerator's number or term. All right, so then we have it equals to 4. Okay, so now let's really read and see what's happening to a. Well, I'm multiplying it by negative 4, and then I'm dividing it by 7. So this is why we multiply by the reciprocal like we did in the last example. So if I'm multiplying, we'll start with dividing actually. I'm dividing this a by 7. So let me undo that by multiplying both sides by 7. And since I'm multiplying the a by negative 4, let me just divide both sides by negative 4. So we're undoing this multiplication and division in one step. So eventually these should become one-step equations. All right, and the reason we do that is because our terms cancel out. I got a 7 up top and a 7 on the bottom. Those are going to cancel. I got a negative 4 up top and a negative 4 on the bottom. Those are going to cancel. And if you're not sure why that works, just multiply them out. Multiply the 7 times the negative 4 and the negative 4 times the 7, and you'll see that those numbers cancel out, and all you'll be left with is a equal to, remember we can write this 4 as a fraction, 4 over 1. So I'll multiply my top numbers. 4 times 7 is 28. And then multiply my bottom numbers. 1 times negative 4 is negative 4. And 28 divided by negative 4 is going to be negative 7. So a is equal to negative 7. All right, next up, negative 3/10 times x plus 8 equals 11. So let's go back to reverse PEMDAS. And remember, the more of these that you can do on your own, the more practice that you can get, the faster it's going to make sense. And trust me, you'll get good at this the more practice you do. So let's undo any addition or subtraction that's being done to this variable. So I see a plus 8. So let me just go ahead and undo that by subtracting from both sides by 8. That will cancel out. So we'll have negative 3/10 x equals 11 minus 8 is 3. So I'm multiplying x by a fraction. So I'm going to multiply both sides by the reciprocal, or that fraction flipped. So I'll do times 10 over negative 3, and on both sides. So here we'll see that the negative 3's cancel because I got 1 up top, 1 on the bottom. And then same thing with the 10s. So I'll be left with x is equal to, don't forget we can write this 3 over here as 3 over 1. And we'll get 30 over 3. And 30 over 3 is going to be 10. I can also see that these 3's will cancel out, and I'll just be left with 10 over 1, which is just 10. All right, 4x minus 22, all of that over 2 equals negative 1. So I mentioned in a previous video that whenever you see an expression in the numerator or denominator of a fraction, like we have up here, go ahead and just instantly throw that into some parentheses. We want to treat that as one term. So now what's happening to the x outside of the parentheses? Well, I'm dividing by 2. So let me undo that by multiplying both sides by 2. Those will cancel out, and I'll be left with 4x minus 22. Remember, the parentheses go away because there's no other stuff going on outside of them once we cancel out that divide by 2. Equals negative 1 times 2 is negative 2. And now this becomes a two-step equation. So I'll add 22 to both sides. Those will cancel. I'll have 4x is equal to 20. I'll divide both sides by 4. Those 4's will cancel, and I'll have x is equal to 5. All right, again, here we have an expression in the numerator of the fraction. So before we do anything, let me just throw some parentheses around that. And now let's do reverse PEMDAS to see what we want to undo first. Remember, we go right to left. So do I see any addition or subtraction? Remember, we're looking outside of the parentheses for the time being. And yeah, I do. I see a -1 right here. So let me undo that first by adding 1 to both sides. So I'll bring everything else down. Negative x plus 5 divided by 9. Remember, these cancel, is equal to negative 100. So now, outside the parentheses, we're just dividing by 9. So to undo that, I'm going to multiply both sides by 9. These will cancel out, and I'll have negative x plus 5. The parentheses go away because there's nothing else going on outside the parentheses. Equal to negative 100 times 9 is negative 900. And then I have this negative, remember that's a -1. -1 times x plus 5 equals negative 900. So let me undo this plus 5 by subtracting from 5 from both sides. Those will cancel, so I'll have negative x is equal to negative 905. And then I'll divide both sides by -1 to get rid of that negative sign there. And all that does to our 905 there is it changes its sign from negative to positive 905. Again, we have an expression in the numerator. Throw some parentheses around that instantly before you do anything else. Now it's happening outside of the parentheses. Well, I'm dividing by -5. So to undo that, because there's nothing else going on, let me just multiply both sides by -5. So these will cancel because we that undoes that divide by 5. So we'll have negative 6x minus 5. The parentheses go away because there's nothing else to undo outside of the parentheses. Equals 7 times -5 is negative 35. And this is now a two-step equation. So I'll add 5 to both sides. These will cancel. I'll have negative 6x is equal to negative 30. Divide both sides by -6. Those cancel, and I'll get x is equal to 5. All right, for this one, I see that I can use the distributive property right over here. There's nothing wrong if you see the distributive property, and just go ahead and do that first and get it out of the way. So let's just do that in this one to show that it doesn't matter. So negative 11 times 2 is negative 22. Negative 11 times negative 7x. Remember, this negative is attached to the 7x. We'll have plus 77x plus 3x is equal to 138. All right, so now looking at this, before we do any reverse PEMDAS stuff, let me just combine some like terms. I see that I have an x term here and an x term here, so I can combine them. So 77x plus 3x is going to be 80x, and I'll bring down everything else. All right, I like to have my variable term, the first one on the left side of the equal sign. So I'm just going to move this guy, this positive 80x, in front of the minus 22. So I have 80x minus 22 equals 138. And then now it's a two-step equation. So I'll add 22 to both sides. These will cancel. I'll have 80x is equal to 160. And then I can divide both sides by 80. And I'll get x is equal to 2. 80 goes into 160 2 times. Kind of like the last one, I see a spot where we can use the distributive property. Just remember that if you don't see a number in front of the parentheses, it's actually hidden, or we just don't write it, but there's a 1 there. So I'm going to distribute this -1 into the terms of the parentheses. So bring everything else down. I'll have 15t, And then negative 1 times 24 is going to be negative 24. Negative 1 times negative 3t is going to be positive 3t, which is equal to 36. All right, again, I'm just going to combine my like terms before I do anything else. So I have a plus 3t and a minus 15t. So I'll just do the subtraction with the coefficients. So plus 3 minus 15 is going to be minus 12t. Then I got this minus 24. I'll just stick that in the front there. Equals 36. Now it's a two-step equation. So I'll add 24 to both sides. Those cancel. I'll have negative 12t is equal to, what's that going to be, 60. 36 plus 24 is 60. Divide both sides by negative 12. The negative 12s cancel. I'll be left with t is equal to 60 divided by negative 12. I know my answer is going to be negative, and it's going to be negative 5. Here, I see two places where we're going to use the distributive property. So let's do them both at the same time. So I'm going to distribute this negative 4 into that parentheses. So negative 4 times negative 4 is going to be 16. Negative 4 times positive 2x is going to be negative 8x. And then I'll take this positive 4 and distribute it here. So positive 4 times 1 is going to be positive 4. And positive 4 times 6x is going to be plus 24x. And then all that equals negative 12. We'll combine our like terms. So here I see a positive 24x and a minus 8x. Add those together and I'll have 16x. And then I have a positive 4 and a positive 16, which is going to give me plus 20 equals negative 12. I'll subtract 20 from both sides. This is now just a two-step equation. So that plus 20 minus 20 cancels. I'll have 16x is equal to negative 32. Divide both sides by 16. The 16s cancel, and I'll have x is equal to negative 2.